Make it so I can kind of see my notes. So how's it going? This is a defensive talk, finding a needle in a haystack using DNS to detect threats. By me, I'm Aaron. Hi. Quick disclaimer. Of course, these are my opinions, not the views of my employer. And since somebody hit me up on Slack on Monday and said, hey man, can you put together a DNS talk? If you run any of my examples in a production system, it might blow up. I also write bad code, so don't run my stuff in production unless you test it. All right, let's do this. So real quick about me, if you haven't met me, I'm a former sales manager turned technical, if that's possible. I did sales management for 9.5 years. I burnt out and I decided, hey, you know what? I'm going to go do something so technical, nobody has any idea what I do. So InfoSec seemed like a natural thing. To get there, I was a network engineer for about 3 years. Now I'm over at Come and Go. I lead the InfoSec team. Mighty team of 2 now. We've doubled our staff. It's awesome. And keep this interactive. Give me questions. Listening to me talk is not fun. But we're going to have fun. So why do we want to monitor our DNS logs? Honestly, because memorizing all the IP addresses on the internet is hard. So basically, everyone and everything is going to use DNS at some point, except for your network guys, because that's how we roll. We access things by IP. As we've seen tonight with our other talks, the bad guys are also using DNS. They can use it for CNC, and they can use it for the exfiltration of data. And so a couple years ago, and if anybody saw my Security Onion talk a couple months ago, you're going to know that I rolled DNS monitoring because I had a PC on my network that was compromised. And it kind of looked like this. So we had our client infected PC making DNS requests to badguy.com. And of course, all those DNS requests are proxied through our corporate DNS servers. So on my firewall IPS, the alerts I was receiving were all sourced from the IP of our corporate DNS servers. So me as a security analyst, very angry, not a happy person, because I saw the first alert and I was like, oh no, the DNS infrastructure is owned. And then I thought about it and I was like, no, that's dumb. It's some PC with a virus. I need to find it. So initial thought, I'm going to go get the DNS logs off our DNS servers. This is going to be easy. This is going to take me like 20 minutes. I'm going to talk to the server team. We're going to spin up DNS monitoring. They're going to let me log it. We're going to pump it to the SIM. I'm going to find this thing. We're going to go get it. We're going to nuke it. We're all going to go home. That's not what happened. Anybody ever go ask the server team to turn something up real quick? Yeah, how'd that roll for you, Brandon? Go away. Go away, right? And I get it. They're busy. They don't want to affect performance. So this was unfortunately 2 years ago. Since then, Microsoft has a great article on TechNet. So if anybody in the future has to go talk to their server team and you want them to turn on DNS monitoring and they say, no, we can't take their performance overhead or hit, Microsoft says, no, that's shenanigans unless you have a very, very large environment. So you can call BS. But be nice to the server guys because they'll shut your accounts off or something. So I was a network engineer for a couple years. Actually, at the time I did all of this, I was also the data center network engineer where I worked. So this was super easy for me. So the thought was I was going to take all of my client DNS requests and copy them to another box that I controlled so I could parse them, log them, search them, and do all the things I wanted. Nobody could yell about performance because it was my box. I was then going to get 2 sets of alerts. My corporate IPS firewall was still going to fire an alert. My box was going to fire an alert. I was going to get both IP addresses. I was going to find and remediate the own box. We were going to do a happy dance. Here's me down in the corner, happy, because I'm always happy. So how do you do this? Passive DNS monitoring. So I took off our core switch. I built a span I filtered just for the client DNS traffic headed to our DNS servers, which is the only way DNS can get out of the environment because we all have egress filtering deployed, right? We drop things outbound from our network. Yes is the answer, right? I'm sure. So how would you actually do this? Bro, IDS. If you didn't see it, Brandon and Nate did a talk on an intro to Bro a couple months ago. It's recorded. It's great. I think of Bro as like pcap to syslog, and it logs it in a format that you can go back and search. It's great. I'm lazy, so I deployed Security Onion. Not lazy. I needed to get this spun up quick. I had an owned box. I had hardware. I wanted the owned box off of my network, so I deployed Security Onion. It's a pre-built Linux distro. Think of it like Kali for Blue Team. It's got all your cool network security stuff installed, running. It's great, and it all just works for the most part. I also this week, after putting this talk together, found another cool tool out on GitHub called Passive DNS. Same thought as Bro, except it just displays it in a graphical format for you. Pretty cool. At the end of the day, I mean, just use Bro. Bro's awesome. Yeah, my last talk, Brandon told me I didn't have enough memes or GIFs, so this one's for you. So I had my infrastructure spun up. I knew we were looking for badguy.com. I started looking for Waldo. Yeah, you see him? I found him too. It took me about an hour. We got the own PC. We nuked it from outer space, made it go away. And I was super pumped, right? When, boom, we found the bad guy. He is off my network. But I got to thinking, I've seen a lot of webinars on this stuff, and I've seen a lot of people write blogs and talk about this. And I'm like, wait a minute. I have all this DNS logging. What else can I do with this? I can go find all the bad guys, right? I can find the cyber criminals trying to steal my credit cards. I can find Russia, China. We're going to get them, right? So time to hunt. Let's go hunting. So I start logging into my box, and I'm looking, man. And pretty quickly, I realized there are legitimate challenges to doing this successfully, considering at the time I rolled this, I was a security team of 1. So me looking through logs with my head in the haystack, I see 1 million DNS logs per day. So you've got one guy on a command line of a Linux box trying to parse 1 million logs. Almost all of them are good. Well, that's trouble. So in all the webinars and stuff, I was like, okay, so what do the hackers look like? Who am I actually looking for? And honestly, I don't find any of these guys on my network. You don't know that guy. He's the one I'm after. That dude, right? Later, and I didn't put it in the presentation, I actually wrote a snort rule to find your domain. If you want it, I have it. I might put it in production and just block the traffic. So anyway, I fail. It's hard. I spent a couple hours just looking, and I got owned. I almost gave up, but that's really not what I do. So what do? I don't know something. I figure somebody smarter than me has done it somewhere. I get on my computer. I start Googling stuff. What's out there? What are the bad guys actually doing, and how do I find them? Because they don't look like Tom when I'm looking at the command line of a Linux box. So I start finding some commonalities and some interesting things. So one of the things the bad guys are doing, they're using domain generating algorithms. So basically it's in their malware code, they're taking a known seed that would rotate over time, in addition with some top level domains that they would control. And they're using it so they're going to seed, say, the date, and it's going to spit out this random domain. So if a government agency possibly finds their stuff and rips it all down, be it domain and or the command and control servers, all they have to do to get their infected bots back is know one of the next domain names that it's going to randomly try, enter a DNS entry for it, register the domain, find another hack server, have another hack server, point it there, and they've got their bots back. They don't lose all their stuff. I actually found some pretty cool code examples that people, like I said, smarter than me have done. This is to compute like all the dynamically generated or domains by the Dire botnet for a day. So if you run this Python code, somebody smart reverse engineer the whole thing, this will spit out all the domains it's going to try to talk to it in one day. Pretty cool. But what's it actually look like from a defensive point? Because honestly, I'm not a coder. I could figure this out, but it's going to take me a couple hours to figure out exactly what this is doing. Once again, people write awesome blogs. This is what the requests look like, right? So this is from the Game Over botnet. So we're seeing a whole bunch of A records for these weird, random, long strings as they're phoning home to their command and control servers. So when you look at it, that's weird, right? If my DNS logs just had these entries, you look at that and say, hey, that's sketchy. I need to go talk to Joe, whose box that is, and figure out what he was doing. So that's one thing they're doing. Other things, as we mentioned earlier, lots of the bad guys are using dynamic DNS. Basically, at this point, the provider owns the top-level domain. The subscriber can generally quickly and or cheaply do the subdomain piece of it. And the reason they want to do that, so a couple examples, noip.com. So Tom could have toteslegit.noip.com. You could have notabadguy.9dns.org. And then, of course, me as a bad guy, I can take those and point that, hard code that in my malware, point that to 5.6.7.8. When the authorities find 5.6.7.8, I can know that I lost that server. I can update the DNS entry to point it to 9.8.7.6, and I still have all my own systems. Pretty cool. Other things, as I was actually researching this and trying to figure out how to find the bad guys, I did a lot of research and reading on known lists of malicious URLs. And one of the things I found in common is lots of them were using what I would consider uncommon top-level domains. So if you tell me what you notice here, my company is only in the United States, so my users don't have a lot of business reasons to visit .ru, .pl, .info. So kind of sketchy, just weird things to look for. More weirdness, just weird requests, as you saw in the Weve bot. This is actually a GIF I pulled out of their PCAP. That's what I do. So if the DNS is going to be used for exfil or CNC, the encoded data has to be somewhere in the request. There's not a lot of places inside of DNS where you can hide data, if you will. It's all visible. And when it's encoded, right, there's a couple different ways it can be encoded: base 32, base 64, binary hex. It's not going to look right when you look at it with the naked eye. And what's this actually look like? So of particular interest to me, a couple years ago, there were some cyber criminals exfilling credit cards over DNS. This is right up that Talos did. But you can actually see what the DNS requests, the A records they were requesting outbound looked like, and the redacted part is where they would have encoded the credit card number, that they were actually using the retailer's DNS infrastructure to exfil the customer credit card data off their registers, because the registers, we all love PCI. PCI says your in-scope assets cannot talk directly to the internet without a proxy. I also do compliance. Hi, it's awesome. Anyway, so they were using the DNS infrastructure to exfil the customer credit card data. When you look at this, if you're looking at the DNS logs, this looks weird. If you're looking for this in 1 million requests a day, you're going to have a bad time. Other ways, I found a red team, like from a college cyber competition, had a nice blog post on basically how they did kind of what we did with WeveBot. They're hex encoding, but they're actually just using the Linux CLI to exfil data. And once again, this is the subdomain. That's their actual data. So if you're seeing lots of DNS requests with weird long hex strings as subdomains, you're probably going to have a bad time. Other ones, so here's our WeveBot, right? Same thing. Yeah, more things from their packet capture that I should have been working on the presentation last night, and I was pulling GIFs out of their packet capture. But yeah, same thing. So you can see the weird long hex string where the hex encoded the data they were exfilling. You can see their, I can't remember, is that the unique identifier, Tom? Yeah. Right? And the thing I noticed, right, is they have all these different data fields separated by periods, probably so you could parse it easier on the back end, right? It's easier if you're writing code to parse off a value. And then the 0, 1, 2, 3, 4, I mean, you see that repeated. You can tell they're taking that and they're putting all that together somehow. Of course, it was midnight when I was looking at this, give or take, so I didn't take a stab at decoding it because I knew you'd tell us. So, right? So we've got all these weird things that we know are happening, but from my perspective as a defensive guy, what am I going to do? I have this huge pile of data, and the only thing I can think is I can't find the needle in the haystack, but I can burn it down, right? I can try to get rid of a lot of this data, So I've got a match. So my initial idea when I first started doing this a couple years ago is taking my 1 million queries a day and just trying to parse through it using, so I'm using Bro, full disclosure, is using brocut on the command line and just taking my 1 million queries I see a day and cutting out a whole bunch of what I would consider common terms just with the Linux CLI, just to get my 1 million queries a day down to something more manageable. Pros, it gives me a list I can actually look at with my limited time to do this and make that judgment call. Is there something super weird and sketchy going on, or does it all look normal? Cons, it's really super easy to overlook things, right? So if there's a CNC server that's CNN.com or something like that, something really common, I'm going to look at it and go, I don't know, or I might have excluded it. And if you're going to do this with Security Onion and Bro, that's where your files live for the current day. You cat the DNS logs, you use brocut, you cut out the query. You only get the unique entries. You cut out a bunch of stuff with egrep. You grep for anything with a period, because sometimes on an internal corporate network, there are requests without a .com or a .net or something like that goofy. So I like to read a lot in my free time between school. I'm in school. I've started reading Practical Malware Analysis. So I built a malware lab at my house over Christmas break because I hate free time. So I've been playing with a lot of CryptoLocker, Locky, stuff like that. So I tested this real quick because that was actual malicious traffic I had in a controlled environment in a Security Onion box where I wouldn't accidentally leak anything corporate to us. So I've got some examples of what this looks like. So my first one, my Locky example, I was able to filter with this query 3,100 DNS requests down to 22. My second example, I was able to filter 8,000 down to 8. What's that look like with Locky? So I knew I hadn't owned, my test box was owned. I ran my query. This is what spit back out of my DNS that was weird. All of those are CNC servers it's trying to reach out to. You notice the weird randomness of the domains. You notice the weird top-level domains they're using. Yeah, when you look at that list, you know it's bad. When you have 31,000 DNS entries and that's mixed in, you're not going to see it. So that's one. I was playing with Cerber, different CryptoLocker type malware. This one was a lot more aggressive and a lot quieter, if you will. And this is probably a whole nother talk in and of itself, playing with these and putting all this together. This particular variant of CryptoLocker, from the time I clicked go on the enable content in the Word doc to the time everything was encrypted and I got the pop-up is 3 minutes flat. It's not even enough time to play with the malware as it's live and look in memory. It's just gone. It hits it, your stuff's gone, it's encrypted, and it makes one call. Well, two. It makes one call to tell. Anyway, whole nother thing. Anyway, that's the DNS entry it pulls up, wang.com or .wang, randoms, pandom, whatever. That's sketchy. There's no reason we should allow that. Rule number two, or idea number two, this is something else I've done. IPS rules. So if you have Security Onion split up, you have either Snort or Suricata. Why can't we have a Bro script or IPS rules to find all the dynamic DNS traffic in our environment and send us alerts? Or why don't we look for the uncommon top-level domains? So as I started researching this a while ago, I was like, well, it'll take me a while to either Bro script it or write the IPS rules, but I can do that. The real challenge is going to be finding the list of top-level domains. Nope, people have done it, which is sweet. That's a GitHub where somebody does this. It was last updated 28 days ago, fairly current. I was like, okay, I can take that data and I can write Bro scripts to actually parse this with Bro and display it so I can get to an alert off it. Nope, that's done too. Pretty awesome. It's out on GitHub. If you want to deploy it, it works. I went with option number 3. There is a great write-up on alienvault.com talking about finding these top or dynamic DNS providers using Snort, Suricata, whatever you've got. And the kind gentleman that wrote the blog post took some time out of his doing this probably for free, and he wrote rules, which is awesome. So you can take these rules that he put out on Pastebin and dump them on your security onion box, or if you have Suricata or Snort. If you have Suricata, you're going to have to translate these just a little bit. It's not hard. Or if you happen to have some sort of a, hypothetically speaking, a not free tool that you would pay for that might be running Snort on the back end, not saying what that is, you can import these. I mean, so at that point, it's really time to have a talk with your business and say, is there a legitimate reason why we need to visit .rus, right? My corporate office is in West Des Moines. I have stores in 11 states. Why are we visiting .rus, .cns, .infos, .tops, .onions? Why are we allowing any of this garbage? And I can tell you what, that conversation's interesting, but I have a tendency just to roll things. So from the day I started looking at this, I had it deployed in production and blocking within 2 weeks because I can sometimes. So we have our systems we have built out in our corporate environment. We're going to take those rules and we're going to put them either on our box off a spam port that can look and alert us so we can go find things. Or like I said, if you have some sort of a purchase system or some other way you can block these, drop them. Knock on wood, in as much time as I've had this deployed, I've broken nothing major. I can't even say I've had somebody come over to my desk and say, I can't get to russia.ru because I want to visit their government's website. It just hasn't happened. I've broken all kinds of other stuff, full disclosure, with some of my other shenanigans. This one is, I've been very fortunate, lucky. So yeah, this is something you can probably do depending on the equipment you have in your environment, painlessly, quickly, maybe for free, and at least get some alerting or dropping and protection. Idea number 3, I thought it'd be pretty cool if I could take my DNS logs and over time have it tell me what are the new DNS requests we saw. Right? So when you look at like Wevebot, you have a whole ton of DNS requests and they're all unique. Why don't I, as a defensive guy, know that I didn't see those yesterday or 2 weeks ago? Why don't I know I've never seen that request before? I was like, this would be super cool. I should write this code. Yeah, guess what? The guy who does Security Onion found a Sans blog post where somebody was talking about this, rolled it into a bash script so you can put it on your Security Onion box, schedule it as a cron job, and just get the alerts. Awesome. So I didn't have to write code. I use it. It's cool. Idea number 4. So more ideas where I thought I would have to write code. What if I could take all of my known DNS requests and compare it against the top or the list of the top 1 million websites? Right? Because why are my users visiting websites that are toteslegit.com, right? I mean, tompole.com. Why are my guys going to tompole.com? That's not common. I would assume, I hope. So I was going to take, and I was actually trying to write this last night before I got distracted with Tom's PCAP. And in my Googles of writing this Python code, I found something cooler. So I scratched this. I threw this away because somebody's done this in a better way. So what if we could utilize entropy combined with frequency analysis to find those weird DNS names, right? They're all super long, they're random, they're weird. Why can't we use like math to find them? I can't write that code, but I happened to find a guy who did. And this was like midnight last night. I found this and I was like, oh, any Python code I'm trying to write right now is not going to be as cool as this. So what this fine gentleman did and put it out on GitHub, he uses entropy to kind of calculate a value, and he's figured out one of those random malware type DNS request scores with the way he wrote his 2 and a 4. Normal DNS requests score more than a 6. Pretty cool. He then ran into some issues reading his blog post where some services will use pseudo-random like subdomains. So he's having some issues. So he thought, you know what we can do? We can throw in frequency analysis on top of this and look for common character like sets, T followed by an H, a Q followed by a U in the English language. And we should be able to use that with the entropy scores to weed some of those out. And they said, but wait, what if I could use a custom table for the frequency analysis, and I pulled in the list of the top 1 million websites and used that in my frequency table? So he did anything I was going to do plus a whole bunch, and it looks awesome. I don't have it deployed yet because it was last night at midnight, and I was in meetings all day today. So this is what his code looks like. He has a Python script. He has a Windows executable. So basically, if you use his Windows stuff and you type -- measure with what the DNS request will be, or the domain, with your frequency table, it spits out a score. You can see Google is a 6, clearing house is a 12. Whatever this long random garbage is a 3. That garbage is a 2, right? So the thought is, if we can take something like this, and like I said, this is totally, I've been thinking about this since last night. What if we could take something like this and roll this as a bro script, right? So we just have bro automatically turning on these numbers and then alert us when we see something between that 2 and 4, right? If we can take that list of the top 1 million websites and use that in our frequency table, and we're cataloging historically the list of all known DNS requests in our environment, not only should we be able to do this and get good data that's actionable, we should get smarter over time. And this should, in theory, get better. I don't know, ask me in 6 months, I'll tell you, hopefully. Cool stuff. And then in that, as I was researching this and playing with this, I found somebody else doing the same thought with machine learning. This I didn't even have time to dig into because machines. Exact same thought. He's using machine learning. He does not have a blog post. He just has code out in the internets. So at 12:30 when I found this, I was not going to pull down random code from the internets and start running it at my house because it's late. I make bad choices anyway. Owning all my stuff at midnight is not a good idea. So that's cool. Idea number 6. So as I was digging through the PCAP, as I was writing my Python code before I scrapped it all, I had the same thought, right? I think Ben talked about it earlier. All these DNS requests are super long. Why are these things so long? This is not normal. This should be an easy Python script just to grab all these logs, look at the request, do a quick length if it's longer than, I don't know, 25, throw the red flags, let's storm the troops, go get the boxes, nuke the boxes. Once again, this is really easy to do with brocut. You would take that spits out all your domains, you just throw it into Python with a length, do a quick check. But once again, see idea number 5, that should work better, be smarter, and I don't have to write Python code. Just sweet, not a developer. Yeah, so scratch that one. So cool, I mean, that's really what I got. How's it going? I talk fast, nobody asks questions. Is that because I talk so fast? How we doing? Questions? Thoughts? No? We're all asleep. What's up? I mean, that's a great question. It'd be just as hard for me to find that, especially if it's Facebook and the traffic is encrypted. I mean, I have to decrypt the traffic to get it. That becomes very interesting. And I've had that same thought is, what if we could run a botnet off Twitter, right, through images, right? Yeah, right. I mean, this is real stuff. From a defensive perspective, that for me will be harder to see than the DNS stuff, because DNS is, like I said, there's only so many places in the DNS packets where you can hide data. And when you hide the data, it's not encrypted, so I can still see it. The challenge for me is having time to go parse through 1 million logs a day and or having something that can parse it for me. When I look at it, I know I'm going to go get a box, and I'm going to take it, and I'm going to talk to the user, and we're going to say, hey, what are you doing? I'm sorry, I need a loaner. No, you can't have the data off your box. We're going to nuke it. But yeah, like the post requests and stuff, if we can see the traffic, I mean, we can do IPS rules, all kinds of fun stuff. You got to get through our web filters. There's a whole bunch of layers you got to jump through, but it's possible. And if you make it look legit, that's going to be harder for me than DNS. Good. Knock on wood, I haven't seen exfil over DNS. I've seen it used for all kinds of CNC stuff, other fun, exciting things that, like the dynamically generated algorithm stuff. Oh yeah, yep. If I'm finding an own box, we see that. Good question. Yeah. Yep. Yeah, right. And that's a great point, Mike. It's really, what are you trying to steal from me? Oh, yeah, I'm sorry. So Mike said one of the things we don't talk about a lot here is architecture. So depending on what you're trying to exfil and what point in my environment you're trying to steal data from, if you're trying to steal data from just a random associate's computer, yeah, you can probably do post requests. You have to get through my web filter, but my web filter is going to be more open than other points in my environment where there is no direct internet access, which is, in many retailers, it should be how most of their environment is configured, is there is no internet access. So you have to find another way out if you want to steal the goods. That's a great point, Mike. Cool. Anybody else? No? Cool. Going once, going twice? Well, thank you.
Mic on. So next month is our 1-year anniversary of existing, which I think is really cool. We started out extremely small with a lot of Casey's Pizza and people bringing their own cases of beer. And we're here with, on average, about 30 people every month, which I think is incredible. So I applaud people who do far more work for this than me. People like Tom Paul and Brandon. Brandon's done a ton of work. Nate. Nick Stark, the list goes on and on and on. But the other thing that we did find out is next month we'll be here. We thought that we wouldn't be, but our sponsor is going to be available, so we'll be here next month. Anything else? Great. So come celebrate this. We should do something for our 1 year, right? Like, I don't know, get a cake or something. Yeah, we'll talk about that.